Hello everyone. So in today's video, we'll learn about interface segregation principle. This is the fourth principle from a solid and it's a very exciting one. So let's just get started with it. So let's just understand it with the definition here. So what does the definition say here? So instead of having one large all-purpose interface, we need to break the interface into smaller, more specific interfaces. That is why the name Interface Segregation Principle. But why do we do so? This is because we want each class or the subclass to only have methods that are relevant to them. A class should only have to implement methods that it actually uses. The last part might be confusing to you, so let me break it down using the examples. Now, before we move on, I want to point out one important detail here, which is that the most common way to create interfaces in Python is by using abstract base classes provided in the ABC module. We have seen that in our vehicle class, we are taking ABC module and then creating an abstract base class here, abstract class. Now, interestingly, this ABC stands for the same. It stands for abstract base class. Now, ABC allows you to define methods that must be implemented by any of its subclass. So let's say I have a method here, calculate insurance cost. Now this should be implemented by all of its vehicle subclasses. So if I go to car, we are implementing calculate insurance cost here as well, and similarly for truck too. But let's say we create a subclass which doesn't implement this. Then in that case, it will raise error. Now, in order to explain interface segregation, let's just add a few methods here. Let's just add a refuel method. And then for this, I don't need any implementation. I'll just do a pass. And I'll also add a method called as recharge. Okay, and that looks correct. Now we'll have to go inside car and truck and implement both of these. So let's just go ahead and do that. In car, we'll come and say refueling car with, let's say, petrol. That looks correct. And similarly, we'll also have a method for recharge. And since the car doesn't have, it's not an electric car, so it doesn't recharge. It only refuels. It uses petrol. So for that case, I'll simply raise an not implemented error and say that cars don't need to be recharged. That looks correct. Okay. And similarly, I'll copy both of those and paste it inside truck. And let's replace this with truck. And this should be diesel. And this replaced by trucks. That looks correct now. Let's now go ahead and also create a class. Let's say I want to create a class called as electric car. And let's just say from vehicle, we import vehicle and then class electric car. Let me just get rid of this. And then we'll have to implement something regarding insurance cost. So I'll have this logic here. I'll calculate the age and then return 2000 if age is greater than 5. Else I'll just simply return 1000. And for refuel, now for electric cars, we don't need any kind of refueling. It recharges. So I'll raise a not implemented error and say electric cars don't need to be refueled. But we'll need to have a recharge method and call it, let's say, print recharging electric car. That looks correct. Now let's go ahead and make changes to our main method. So I'll go ahead and simply do from electric car import electric car, and then I'll initialize something here. So let's say electric car. Okay, that looks correct now. So I'll try to use this Let's say I want to have car.refuel and truck.refuel. I think I'll get rid of this for now. And we can have for electric car, I'll simply do electric car.recharge rather than refuel. Let me go ahead and just run it. And it looks correct. There was no error thrown and it was able to refuel it. So that looks correct. But what if I run this? Let's say electric car dot, and then I do a refuel instead of a recharge. Let me just run this. Oops, I see an issue here. It says not implemented error. Electric cars don't need to be refueled. It's because we haven't implemented it. It doesn't make sense to have a refuel method inside the electric car. Similarly, if we get rid of this and then just simply run car.recharge and try to run this, it again throws an error. Says that not implemented error, cars don't need to be recharged. That makes sense. This is again because for cars, having a recharge method there inside it and saying that it's not implemented, this doesn't make sense at all. So what should we do? We should go ahead and break down our vehicle into different interfaces. We'll break down this vehicle into different interfaces which are smaller in size and more granular. Here we are trying to force all of these classes, car, truck or electric car, to implement all of the methods that is present in vehicle, which shouldn't be the case. We should have smaller interfaces from which all of these car, truck and electric cars can take those necessary methods there. So let's now try to fix this. How will we fix it? Let me go ahead and create a new file. Let's call it, let me call it fuelable. And in here we can have all the code regarding the refuel part for that vehicle. So let me go ahead and just do from ABC import ABC and abstract method, and let's call it this abstract method and have a refuel here. Now very similarly, we'll have a class or abstract class for rechargeable. So let me go ahead and do that. So I'll create a new file here. Let me first copy all of this and then simply create a file. Let's call it rechargeable.py. That looks correct. So let me change this to rechargeable, and I should probably change it to recharge. Looks like I have made some naming issue here. I should probably rename it to a smaller case viewable. Let me try it one more time. Okay, so that looks correct now. Now let's go ahead and get rid of all of these methods from here because we already have it in viewable and rechargeable. And for these classes car and truck, what I'll do is I'll also have a viewable because it's a viewable. And I'll also need to import viewable from viewable. That makes sense. And I'll also need to get rid of recharge because that doesn't make sense. For truck, I'll do the same. I'll go ahead and do from viewable import viewable and change this to viewable and get rid of this again. And that looks good now. Similarly, for electric car, I'll need to import from not viewable. There should be rechargeable. I should import rechargeable and then I should have rechargeable, and I'll get rid of refuel because electric cars don't get refueled, they get recharged. So that looks correct now. Now this way, using interface segregation, we segregated our earlier vehicle class or abstract class interface to multiple abstract classes or interfaces. And now if we make changes to our main method, let's say I want to have electric car dot recharge and car dot refuel, that would totally work perfectly. So that looks good now. And if we even, because we won't be going into a situation where we'll go ahead and do car dot recharge, because it wouldn't pop up also. That method doesn't exist inside car. So we won't get into any kind of runtime issues. That's what interface segregation does. So just to summarize what we did here, we had an abstract class called as vehicle or an interface called as vehicle. It had multiple methods here for refuel and recharge. And for car and electric car, all of those had to implement those. It was a necessity for both of those subclasses to implement both of those. And that was throwing error in our main method when we were trying to run all of that. And that is why we segregated our vehicles method into multiple other interfaces called as fuelable, rechargeable, so that it's convenient for car, truck, or electric car to take relevant methods from them. And that is why we have a rechargeable here and fuelable here. And even if you see, some of the methods from vehicle are taken for all of these classes, car, truck, and electric car. The vehicle part is common there. So since we are taking it from vehicle, this needs to be implemented. Now we can say that we have understood interface segregation properly. But again, a curiosity kicks in my mind. What happens if I don't follow interface segregation? Let's go ahead and understand that. So what happens if we don't follow it? First thing is, classes may be forced to implement methods they don't need, leading to irrelevant code or not implemented error placeholders. That's what we saw, right? These classes like car, electric car, these all classes were forced to have those methods which were irrelevant to them. And in that case, we just simply added a not implemented error or raised the not implemented error. And that led to unexpected runtime errors. By mistake, somebody can come in and write a code which would basically run those methods which are not implemented. And that would be chaotic. The second consequence that we see if we do not follow interface segregation principle is that adding new features or modifying functionality becomes very hard. Why are we saying so? Because if you see, if I had the vehicle class here, let's say I have another method called as abstract method. Let's call it defined as load cargo, which is only relevant to, let's say, the truck and not relevant to car or electric car. So in that case, what we did that we have to go into each and every class, car, truck, electric car, and we have to implement this method. Don't you think that's a bad design? And that is why we use interface segregation to segregate into very relevant small abstract class or interfaces. Hope that makes sense now. Now, after this discussion, what are some thumb rules that you should remember and take away from this video? I would say that do not cram all the functionalities into a single interface. Instead, split them into smaller interfaces however you can. So, I just rephrase the whole interface segregation principle to you in a different language, but bear with me. So, whenever you are in a state where you are having methods which have not implemented error, you get into a situation where you have to do a not implemented error for any of the methods, then you should probably think about this interface segregation principle and break into smaller interfaces. So that's the first thing here. The second thing is when different classes share but not all the behaviors, like in our case, we had car, where is sharing some methods from vehicle and some from fuelable. Similarly, if we see for our electric car, it's taking from vehicle and rechargeable. So that's what it's saying. So when different classes share some but not all behaviors, considered using composition with smaller interfaces instead of having a broad interface like our previous vehicle class where we had all the methods there. Hope that makes sense now. Well, that's it for this video. Hope you guys understood the interface segregation principle. It is, in my means, the easiest of the lot, easiest from those solid principles. And in the next video, we'll learn about dependency inversion. So see you there.